Hello and welcome to a video on isosceles triangles. So we're going to develop theorems about isosceles triangle and we're going to prove them and use them. So let's move on. So some of the triangles Jason needs to replace are isosceles triangles. So remember in our last lesson Jason was replacing the glass triangular stuff on the outside of that little shape thing building. Okay. So he needs to know what an isosceles triangle is and wants to be sure he's correct. So let's talk about isosceles triangles. So you've seen it before in middle school. The name isosceles is derived from the Greek iso, meaning same, and scales, meaning leg. So same legs, okay? So define an isosceles triangle. Here is the definition. So an isosceles triangle is a triangle with at least two sides congruent. So if it has two of the same sides, it is isosceles, okay? How we mark that is same side, so with the side tick marks, okay? Now we're gonna label our triangle down here. So it wants us to classify and label each side and angle using the term vertex angle, base angle, leg, and base. So the vertex angle, vertex is the peak of something, so it's the top. So this angle up here is your vertex angle. Okay, so where the two sides that are congruent meet up is the vertex angle. Okay, that means these angles down here are base angles, and the sides opposite, or the angles opposite of the sides, are congruent. Okay, so for example, this side is facing this angle, and this side is facing this angle. So these are your base angles. Okay, so in an isosceles triangle, the two bottom ones are your base angles, and then the tippy top where the two congruent sides meet is called the vertex angle. Okay, let's label our sides now. So we have legs and we have bases. So the bottom one is your base, and then the two tick marks are going to be your legs. So leg and your leg. Okay. So that is an isosceles triangle and all the vocabulary words that you need to know, okay? So let me know if you have any questions on that. But what appears to be true about the base angles of an isosceles triangle, okay? They have the same tick marks, okay? They kind of look the same, and they are the same, okay? So we're going to write an if-then statement known as the isosceles triangle theorem, okay? So if something, then something. So, if a triangle is isosceles, then the base angles are congruent, okay? So if a triangle is isosceles, meaning that it has at least two sides the same, then I know the base angles are congruent, okay? So I'll give you a second to write that down. So again, the base angles are opposite of the sides. So for example, here is this tick mark, here is the angle opposite, okay? So the base angles are located opposite of the side. All right. Let me know if you have any questions on the isosceles triangle theorem. Otherwise, we're going to look at a proof of why it exists. All right, so I have a proof to my left. So it says the proof of an isosceles triangle theorem begins by drawing the bisector of the vertex angle. Okay, so what I have to do is I'm going to draw a line straight down from B and create an angle bisector. So let's do that with me. It's a really terrible thing. Okay, so I'm going to start my proof off by drawing. I'm going to erase that. That's terrible. We're going to get the line tool out. Okay, I'm going to drop down an angle. Boom, that looks way better. Okay. All right, so let's talk about this proof. If ABC is isosceles, I know that AB, they gave me a tick mark here, is equal to CB. So that's given. They gave that to us in our picture, okay? The reason I know ABM, okay, where this bisector hits, I'm going to call it M, by the way. So ABM is this angle here. The reason I know that this angle is the same as this angle is we drew that bisector line, so that's the definition of an angle bisector. Okay. The reason I know that BM is congruent to BM, that'd be this mark in the middle, that's the reflexive property. Okay. The reason I know triangles are congruent, so that's the side, 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 angle, stuff we learned. I have a side, and then an angle, and then a side. So that would be side, angle, side. And then the reason I know that angle C is congruent to angle A is right after that would be CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so here is why my two base angles are the same, given this proof. Okay, so if I know a triangle is isosceles, then I know its two base angles are the same. Okay, so we have proved that the corresponding parts of congruent triangles are congruent, and that's why it exists. How cool. Okay, all right, let me know if you have any questions on why we are allowed to prove base angles are the same in an isosceles triangle. Otherwise, we're going to move on to some practice. All right, so the measure of a vertex angle of an isosceles triangle is 80 degrees. What is the measure of the base angle? So first, we're going to draw a picture because that's going to help us out. So vertex angle, remember, is the tippy top angle. So I have this, okay? Vertex angle is going to be 80. So this top part in the inside is 80, and if it's an isosceles triangle, I know the two sides that meet up with the vertex are congruent, okay? So I'm trying to find the base angles, okay, which I already know base angles have to be the same, okay? So there are two ways of doing this. I'm going to teach you the shortcut way first. So we know a triangle equals 180 degrees. So start with 180. I know the vertex angle is 80, so I'm going to take that away and see what's left over. So 180 minus 80 is 100 degrees. Okay, so I have 100 degrees to split evenly between two things. So I'm going to divide up 100 evenly between you and me. And so that's dividing it by 2 to get 50. Okay, so I know my base angles both have to be 50. That makes sense because 50 plus 50 is 100 plus 80 is 180. So that works out. Okay. Now if you wanted to do it the algebraic way, I know my base angles are the same. I don't know what they are, so I can call them x. Okay, so then you could write an equation of a triangle and say x plus 80 equals 180 using our triangle sum theorem. Solving this is going to get you the exact same thing of 2x equals 100 divided by 2, and you're still going to get 50. Okay, so you can pick if you want to do it the algebraic way, you can, or you can kind of use some problem solving skills. If I know the top angle is 80, I'm going to subtract it to see what's remaining, and then I know these have to be the same, so divide it by 2. Okay, so if you know the vertex angle and you're finding the bases, you're always going to divide by 2. Okay, all right, I'm going to erase this red real quick. All right, let's take a look at another example. The measure of one base angle of an isosceles triangle is 25. What is the vertex? Okay, so on these, they only have to give you one number. So let's draw a picture. It's an isosceles triangle. I always draw it right side up to help me out. So the base angles are your bottom ones. One of them is 25, and I'm trying to find the vertex angle. Okay, well, I know base angles are always the same, so I can go ahead and copy and paste that 25 over, and then I have two measurements of angles of a triangle, and I'm trying to find the third. So I know triangles have to add up to 180. I'm going to take away what I know, which was 25 and 25. So 180 take away 50 is 130. Okay, so that has to be the vertex part of my triangle. Okay, again, you could do this in algebraic way if you wanted to. If I don't know the top, I can call it x. So then I could say 25 plus 25 plus x, because all the angles of a triangle are going to add up to 180. 50 plus x equals 180. And again, you still get the same answer doing it the algebraic way. Okay, we're just kind of doing one part in our head. You can do one part physically, mathematically. Okay, So let's kind of overview that. If you know the vertex angle on number 4, we subtracted it and divided it. If you know the base angles, you're copying it or duplicating it or multiplying it by 2 and then subtracting it from 180. Okay? And those are your two kind of options. They're either going to have to give you the base or they're going to have to give you the vertex angle. Okay? All right, let's take a look at some more trickier problems because they give us more variables. Okay? Move my face. All right. So number 6, I want to solve for x. The reason I know it's an isosceles triangle is because I have two legs that are the same. So I have this 5 and this 5, meaning that my legs are the same. So I'm going to go ahead and mark my base angles. So opposite of this red side is over here. The opposite of this side is over here. So these are my two base angles, meaning that this up here is my vertex. Okay? So I need to find this missing angle, and if I know these are the same, I can go ahead and copy and paste it over. So if they're the same, this one's also going to be 2x plus 3. So now I know all the measures of my inside of my triangle, so I can use my triangle sum theorem to solve for x. So let's do that. So I'm going to say 3x minus 1 plus my other angle 2x plus 3 plus my other angle 2x plus 3, I'm going to move my face, equals 180. Okay, so all three of your angles added together equal 180. I'm going to add like terms now. So 3x, 2x, and 2x, 3, 4, 5, 6, 7x. 3 and a 3 is 6, minus a 1 is going to be 5. Okay, so combining your like terms, I'm going to subtract 5 now. 7x equals 175. Divide by 7, I don't know what that is. 175 divided by 7 is 25. So x is 25. Okay, and I'm done because it wanted me to solve for x. If it said find the base angle, I would be substituting in my value for x. Okay, so let's check it for the heck of it to see if we're correct. So if I substituted in here, 2 times 25 is 50, plus 3 is 53. So my base angles are both 53 degrees. Let's plug it into the top, substitute it. 25 times 3 is 75. Minus 4 minus 1 is 74. So then let's check that out. If I add this angle and this angle and this angle, I better get 180 degrees. So 53 plus 53 plus 74. It worked out. I got it right. Okay? So if you're ever on a quiz and you want to make sure you're correct, you can always substitute your answer in to find your angle measurements to see if you're right. All right. So that's an example of how using algebra and isosceles triangles. Okay? All right. Let's look at one more proof problem. Goodbye, face.